Hello all. Today's video is regarding BlueChi from RedHat. So in the previous video we have discussed with respect to the importance of an orchestrator for running containers in the car. So now consider a scenario where you have three nodes. Okay, so three nodes being three issues. Say node 1 has one container running, node 2 has 3 and node 3 has 2 containers running. Now if at all we see the traditional setup, the containers are running based on some container runtimes, but there is no orchestrator available which knows that which particular node is having what containers and how many of them. Okay, so if at all we see from a traditional cloud technology point of view, in order to have some container running on an orchestrator and all, so basically you have Docker Swarm, you have Nomad, you have Kubernetes and all. But in our previous video we have discussed that they are not suitable for the automotive use case. Now here comes with other complexities, like if at all you have an automotive operating system, you have a Linux operating system in an automotive use case, then you will not just be running containers, you will have to run some basic binary targets, which are maybe some legacy piece of code, and for some other applications maybe like infotainment, we even might have to run some kind of Android related applications, mostly in infotainment system. So in that case your automotive Linux should be having a container runtime. For this example I just took Podman. It should be able to run the binaries, and it should also be able to run the Android on a virtual machine or something in those lines. Now in order to do that, so Red Hat has proposed something called as BlueChi, and Red Hat has some advantages as far as I know compared to other competitors in this space. Reason being, Red Hat already is taking care of Podman, which is one of the popular container runtime. The reason being, Podman is kind of preferred over something like Docker in an automotive use cases, because Podman runs as non-root, but Docker runs as root, and because of there are many differences, advantages for Podman, but this is one of the primary, because of which what happens is that avoids lot of security concerns, because Podman runs in non-root. Anyways, on top of that, Red Hat has its own version of operating system for automotive, which they called as AutoSD, based on CentOS, and they anyways have BlueChi, which is basically the container orchestrator across multiple nodes. Now if at all we come to the situation like BlueChi has something like this. So earlier we have three nodes, they are independent, no other node knows, no node knows what is running in the other node. But when it comes to BlueChi, basically what happens is, say the same thing, node 1, node 2 and node 3. So node 2 is for this example is taken as the BlueChi controller. The node 1 and node 3 registers itself to the node 2, saying that we are all the agents. So the controller itself has another agent. So based on this, the controller knows that there are three nodes, one is node 2, node 1 and node 3, and it also knows that in node 1 there is only one container running, and in node 3 there are two containers running, and it itself has three containers running. Now this is a small image which I have picked from the documentation. I will anyways link the documentation in the description of this video. So if at all you see that there is a CentOS which is running on a high performance computer, and you have a systemd, and on top of this systemd you have a Podman runtime, and you have something called as a QM partition, which itself has a separate systemd and a separate Podman. And if at all you see, based on this thing, so you have some applications which are maybe accelerated applications or whatever applications which can directly run as binaries or its own standalone operations, and you have you can run some another set of applications in the form of a container, and you can even create a virtual machine and you can run something like as an Android Auto. Okay, we will go deeper with respect to QM partitions in the upcoming videos, but for now let us have this video only for the just for Eclipse BlueChi basic understanding. Now anyways, we have gone through this particular slide. So if at all we see you have a main node over here and you have two workers, or maybe you can call it as two agents. So you have a main, you have worker 1 and you have worker 2, and in the main what is BlueChi? So what exactly BlueChi is like, it is taking advantage of the existing systemd to run a container by converting the container file into a .service file and running it as a service using systemd. Okay, so because by default all Linux have systemd, so BlueChi is a wrapper on top of systemd, which kind of adds an additional capability of the number of nodes running around, and on top of it, how BlueChi can specifically target a node and spawn a container or delete a container or get logs of that particular container. So this is how BlueChi works, by using the underlying existing architecture and software assets which were built over a period of time. So if at all you see that you have a main, you have worker 1 and you have worker 2, all these three are connected via DBus. Okay, now you have a BlueChi controller, so you have a BlueChi agent over here connected via system bus, and as I said earlier, the BlueChi controller itself has a separate BlueChi agent which is also connected via system bus. The BlueChi agent speaks to the systemd, and what it does is it takes the .service files, which are the containers which we want to run, and it runs it via systemd service. Okay, and this basically uses the systemctl daemon, and on top of it there is a wrapper on top of it which is the BlueChi-ctl, so which gives the CLI commands to operate across. And if at all we want to write our own applications, then we can basically trigger these dbus daemon to run whatever application or whatever operation which we want. Like if I want to see the list of pods which are running, list of contents which I am running, I can write a code instead of doing a BlueChi-ctl, the node name and the list of pods which I want to see. Now this is the BlueChi documentation, which basically tells about the dbus APIs, how do you use the dbus APIs. So we basically use the existing dbus algorithm libraries which are quite popular and quite available. So we can basically, so they are providing examples with respect to C, C++, Go, Python and Rust. You can take this as the base and you can start off however you like to start experimenting. Now if at all now let's get into the details on, if at all I have to run a container by name Nginx in using BlueChi, then how do I do it? Now how it generally happens is, in a container file, say if at all this is the image which I have, okay, say I have a Nginx image, using Docker or something, if at all I have to run, then I will do a Docker run. I will give the name of the image which I want, and I will say, so the name of the container which has to be coming out of this, and I will give the name of the image, and the container simply spawns out of the image. Okay, now with respect to BlueChi, things are a bit different. So what you do is, you initially have to create a .container file. You have to say that the image is this, the container name is this, whichever the container name which you want, the port and the sleep time. Okay, now once you do this particular thing, you create a file at the location etc container systemd nginx.container. You can give whatever name you want, and this is the content of it. Okay, once you have a content of this, as you know, systemd basically runs the service files, .service files. So there was earlier a tool by name Quadlet which was available, which was a separate project altogether. This has been merged with Podman. I think maybe an year or two back. So what Quadlet does is, Quadlet is a tool inbuilt which creates a dot service file out of a dot container file automatically. Okay, so how does it do? So you have a dot container file. The dot container file you have placed it at etc container systemd nginx.contain this location. And once you are done with this, so basically what we do is we do a systemctl daemon reload. So once the daemon reload happens in that particular specific node, then what happens is it creates a dot service file which is automatically generated. So if at all you see, the content of the container is the same over here, and it says what is the unit you want, and it even tells the services. Okay, so what it is trying to say is, if at all you want to start this particular container file, you are using the etc start equal to user bin podman. Okay, so the container runtime which it is using is podman. It is not, as far as I have gone through the documentation, I have not tested it myself, but as far as what the documentation says is, it is not mandatory that you have to use podman for this. You can have Docker or whatever you want. You just have to make sure that you are selecting the proper runtime, and once you do a daemon reload, the dot container file is converted to dot service file with whatever container runtime which you want. Now once this is done, this particular file is basically generated at run systemd generator. So this is a created file using the tool Quadlet, okay, which was earlier a separate project, but now it is part of Podman. Okay, it's basically tool. So now that we are done with this, so things go like this. So there is a BlueChi controller. The BlueChi controller, when it says that I want to run nginx in this particular node, which is node 2. Okay, there is a mistake from my side. It has to be a node 2 over here, not node 1. So what this particular command which is given is BlueChi start node 2, the name of the nginx.service. Okay, so prior to this, the BlueChi controller will do a daemon reload in this particular node 2. Okay, when you do a daemon reload, the nginx.container file which is over here in this particular location will create an nginx.server based on the Quadlet which is available in the same location. Once you are done with that, then you give a BlueChi start. You can give via the CLI commands like CTL commands, or you can basically use your own application. So you can give a BlueChi CLI command like this, or you can write a code to trigger the dbus daemon. Okay, once you trigger that, basically what happens is, now that this trigger has come saying that BlueChi start that node 2 nginx.service. Now this particular controller routes this particular command to this agent, because this is of node 2. Okay, and now once the command is received by the BlueChi agent, it has to trigger the systemd. So what it does is, it converts this particular command to systemctl start nginx.service. It no longer need the node name, because it anyways knows that it is targeting this systemd only. Okay, now that the systemd is targeted, now the systemd uses the underlying container runtime, and it basically executes the particular command to spawn this container which has been shown earlier. So exec start, the container runtime, and the name of the container. Okay, now once this is done, you will be having the container spawned up. Now if at all you do a systemctl status nginx.service in this particular node, which is node 2, then you will be able to see, this is what I did, then you will be able to see that the nginx container is up and running. I just made it as red. I didn't want the IP to be exposed, and the machine which I am doing over here is the AutoSD operating system, which has been which I have explained it earlier. So this is the AutoSD image based on CentOS. Yeah. So when we do a systemctl status nginx.service, we can see that this is the log. The nginx service is basically up and running. Okay. Now, if at all, as you know, as I have told earlier, that the systemd or means the BlueChi is using systemd, and systemd is inherently using Podman. So ideally, if at all I want to kind of see whether a container is running or not, I can do it even with Podman also, because at the end of the day that is what is happening. Okay. Now, so this is via systemctl. Now if at all I do a sudo podman ps, you can see that the particular container is up and running over here. Okay. And the podman has even the control of deleting the particular deleting the particular container as well. Okay. So it is not like just because it is created via systemctl, it should be turned off only with systemctl or BlueChi or whatever. That is generally the way it has to be done. But I was just experimenting out, and this is what I felt like. Okay, fine, this is something which is I wanted to share. So you can do a podman rm-f, and that will basically kill the particular container, which is the nginx container. And when I do a sudo podman ps again, now there is only one container, there are no two containers. Okay, so this is few of the experiments which I did with respect to BlueChi, how it is using the existing systemd infrastructure and how it is using the existing the container runtime, which is quite popular. Okay, in the coming videos we will get into some of the deeper discussions with respect to Eclipse BlueChi from RedHat. Thank you. Thanks a lot for your time.